sessions had been going on. Do you have any questions? It can be anything. It can be something that you want to provide feedback for our faculty members. And Mr. Shirley is your instructor. Is there any feedback you want to give Mr. Shirley? I know it's awkward because he's in the classroom, but it can be something that'll allow us to know that this part of Zoom's not working, this part of Zoom is working, anything of that nature.
Zoom instructions, step-by-step courses for instructors.
Come again? I didn't quite understand.
Zoom step-by-step courses for instructors, like how to cast your video, how to cast your screen.
So break it down into bullet point instructions.
Like, is she talking about like teacher professional development?
Yeah, so you want the faculty to kind of
know the technology.
Know the technology and break it down step by step.
I could agree with that.
Yeah, that way if something does happen, it doesn't take like you're not casting
like Mr.
You're
Shirley
not watching a video of your screen.
Okay. Just know the technology.
I'm not talking really about Shirley. I'm just talking about other professors I had like last semester and
oh, I was just using him as an excuse and
yeah.
He's the one that's here, so I'm gonna pick on him. Okay.
Hey, be nice.
So that way we're not so dependent on our IT people to fix the issue right there and then. Our faculty members will also have knowledge of
I mean, there's
what's going on.
There's a mixture there, right?
Yeah.
Because we come in, even in this class, where it worked one day and then the next class period, the audio doesn't work on that. So now I had to improvise and do the audio through my laptop, but then still record through. I mean, so it's a very...
But not everyone is tech savvy.
Yeah.
So we need everybody to have the same knowledge across the board.
There's a gap there. Good luck on fixing that one.
And you said this writes on the board?
Yeah.
Okay, so I'm not gonna take up too much of Mr. Shirley's class time. This gives me something to start and work with, but on the board, I'm gonna write my email address. So you guys can email me anything that you come up with, remember to ask about, forget now, remember later sometimes. That's how it works. And I will see what I can do on our end and kind of just spread the word about what our students are looking for and what's going to help us help you. So I thank you guys for your time. Any last questions? All right, well, you guys have a good day.
Awesome.
Thank you.
So are you planning on like having, once you get through all this?
Once I get through all of this, maybe like showing any videos and then resume like Trailblazer talks and kind of set the platform.
I bet I know faculty would like to know too.
Yeah, that way the faculty are in on all the feedback.
Just
but I need more buy-in from faculty.
Yeah.
None of you guys showed up to my Trailblazer talk.
No, it was a rough time for me. And I think, a lot of us are home still. It's weird. There's some people only coming 2 days a week.
Oh, I know.
Because they're online, but then like they're seated as Tuesday, Thursday, So,
and that's also.
Yeah, I have all my classes, so it's kind of.
I'm listening, Rose. You scared me there, bud.
Yeah, scared me too.
Sorry.
No.
But yeah, faculty need to know, and then I need to know what works for everyone.
Oh yeah, totally. Yeah. No. And it'll be hard getting to that point, but I think there's probably a consensus out there that where it can affect the most people, right?
So I'm just collecting data and then I will disseminate it out.
Yeah, let us know. This is interesting.
All right, thank you. I have Michael Thomas and Kelly. I need to set up with next.
Okay, awesome.
Thanks.
See you, Sarah. Okay. Okay, guys. Woo, now we're here. Okay. Today, here, let me take my head off so you can see my face with the mask. So today we're going to go over 2.6, but before we go over 2.6, I want to ask you guys if you had any issues with 2.5. Online. Remember, you had to watch 2.5 because we missed last Thursday because I'm not feeling well today either. It's weird.
Transformations are very confusing.
So, yes, they are. And that's why I'm going to give you time. Actually, I'm going to give you time today if you want to ask any questions on transformations. I got a hat here and everything now. Any questions about transformations. And now we are going to stick to just the rigid transformations, which is the only thing I lectured on that video. And then in the homework, I only gave homework on the rigid transformation. So up, down, left, right, and then rotate, reflecting around the X and the Y. Any specific questions before we get going? Today, we'll probably, we're actually kind of a day ahead right now if you look at it. So if you look at the schedule. So what we'll wind up doing is actually, I probably won't finish 2.6 today. I'll go over the first half and then I'll finish it tomorrow and then maybe start on 2.7. We'll see. But it's better to be a little ahead than a little behind right now. Okay. So let's look at, if you guys don't have any questions about 2.5, and if you come up with some later, that's fine as well. Just email me or come to ask me in class. But 2.6, we're going to talk about composition functions. In the very beginning, the first thing your book talks about is the domain. And we're going to review just a minute on the domain, because this was that day that I had to miss at the beginning of the semester. So the domain of functions. And we know this is just where the X exists, right? So it's on a graph, visually it's just where the X values occur. But equationally, there's two things that can happen with domain. I'm going to do these with an example because they should have been in that other video. But it was, if we had something like 2 over X minus 3, right? We've got this example, f of X equals 2 over X minus 3. And I ask you for the domain. Well, what we have going on here is actually a domain restriction. It's a value that X can't be because the denominator could be 0, right? We don't know how to divide by 0. It's one of the real two glitches in algebra. The other glitch is the other domain issue. So what we would do is if we got 2 over anything, we don't worry about the numerator, just the denominator. I'm going to set whatever is in here not equal to 0, because we know that X minus 3 can't be 0. If X minus 3 equals 0, we have a division of 0. Now this one's pretty easy. We just solve it out and we wind up finding that X cannot be 3, right? So X can be anything it wants to be, right? That's the domain of the function. X can be anything it wants to be. It just cannot be 3. So if I was going to state the domain, which we use interval notation, in this class, it would be negative infinity to 3, union 3 to infinity, right? This means X can be anything less than 3, that's the left part, and X can be anything greater than 3. Now the parentheses mean that we can't be 3, right? Remember, if we were going to equal the end points, we'd have to use brackets. So those parentheses just mean that we kind of make a little skip right over 3, okay? But again, this is like the first glitch in algebra that was kind of noticed is how do you divide by 0? 2 divided by 0 makes no sense. Like if you plug 3 in here, what happens? Well, if you try to plug 3 in, you get 2 over 2 minus, or 3 minus 3. You wind up with 2 divided by 0, right? And remember, we said anything divided by 0 is just undefined. We don't have a cool name for it. It doesn't get a Greek letter. It doesn't get some, famous Greek philosopher's name. Nothing. It gets undefined because that's all we really know about it. We just know that it's undefined. We're going to talk a little more at the end of this chapter at what's happening close to 3, but we really don't know what is happening at 3. Yeah, that's a glitch. Okay, So let's look at the other red flag with domain is the even roots. Let's just put the same x minus 3. Even roots, right? We've got a square root here. And the other issue with domain, so it's dividing by 0 is the first glitch. The second glitch, or red flag, I think is probably what I called it in the video. The second red flag is going to be taking square roots of negatives. We don't know how to do that either, right? We don't know how to do that so much, yet it was so intriguing. Mathematicians came up with a whole area of mathematics that's just devoted to imaginary numbers, right? This is an imaginary number. If you take a square root of a negative, you wind up with an imaginary, right? The I value. So if you want to go on to graduate level mathematics, maybe even like some senior level mathematics classes, you might jump into complex algebra. And complex algebra really, or complex mathematics, complex numbers is actually the course that I took. And it really dives into the imaginary and what's going on with the imaginary. What do we know? What do we don't know? And for now, though, we're just going to call it another one of the red flags. It's another glitch. I can't take a square root of a negative. So what that means is underneath this radical, this x minus 3, it can't be negative. So the way you write that in math lingo is that it's got to be greater than or equal to 0, right? That means it can't be negative. It's got to be greater than or equal to 0. If it could be negative, it would just be less than 0, right? So we need all the values of x that make this statement true, where these x minus 3 is greater than or equal to 0. So now in this one, you just solve it like an equal sign. And you wind up with x is greater than or equal to 3. And again, we write this in the interval notation. So if x is greater than or equal to 3, the smallest our x value can be is 3, and it can equal it, right? So it's going to get a bracket. And then x is greater than that. So we go to positive infinity, right? So this would be our actual domain, guys. I was asking this on the test. Let me box those in. That's our actual domain. That's the domain of these functions, okay? And look, if you plug any number in this interval into this equation, you'll wind up with a value back, okay? If we chose some random number, let's say like 10, okay? We get the square root of 10 minus 3. We get the square root of 7. That's okay. It's irrational, right? But it's not imaginary. It's fine. The square root of 7's out there somewhere. It's 2 point something or another. But if we choose something not in this interval, let's say we chose 1, right? 1's not in that interval. And if we plug that in, we wind up with 1 minus 3. Well, 1 minus 3 is a negative. It creates the negative issue we were talking about, right? And actually, the square root of negative 2, we would just say I. Square root of 2. Look, notice, if it's not in this interval, for this example, for this type of equation with an even root, if it's not in this interval, it creates an imaginary. That's why it's not in the domain, okay? If it's in the domain, it gives us back a nice real number. I mean, you can say the same over here. If you choose any number not 3, you're going to get back a nice regular number over here, right? If you choose like 5. If I plug 5 in, 5 minus 3 is 2. 2 divided by 2 is 1. Oh, that's a nice number, okay? But by nice, I mean it's just a real number, okay? Questions about that for you guys on Zoom, ask me while I'm erasing. Okay, I think I've ran out of room under here. Well, what if we don't have this issue, right? What if we have like z of x equals, let's just do a nice quadratic, like x squared minus x minus 12. Okay, what if we've got z of x here equals x squared minus x minus 12? Well, okay, let's think about this. It doesn't have a denominator with an x, right? Like the first example. So we're good there. It doesn't have that root flag. It doesn't have a square root, right, or an even root. Your book sticks to the square root, but it doesn't have a square root or an even root. We don't have that root flag. So it turns out if we don't have either of those glitches, this domain's going to be all real numbers. And I think I've kind of showed you guys the short, there's two ways to write all real numbers. You could use this R shortcut. The test generator that I use on the test is probably going to do the negative infinity to infinity because it's interval notation. Okay. Okay. I'll hide some water. Okay. So I'm going to give you a few of these and I want you to try them yourself. Okay. We're going to do a little mini quiz on domain. A little mini quiz on domain. I'll do an A, B, and C. How about that? Okay, for A, and all I want you to do is find the domain of the function. For A, I'm going to give you f of x equals 3x over x squared. Let's use that same equation. X squared minus x minus 12. For B, let's do B down here. For B, we'll do g of x. And it's going to equal 4 over x squared plus 9. That's a curveball question. And then C will do h of x equals the square root of negative x plus 9. Why not? And then D will do one more. We'll do f, g, h. We'll do j of x. Why not? J of x equals 4x plus 2. Okay, try those four. We'll treat it like a little quiz, like it's a test. Make sure we understand this domain stuff. Okay, I'm going to start. If you're still working, just keep working. But I'm going to start going over these to see that we're in the right direction. Okay. So first off, this f of x, 3x over x squared minus x minus 12. Well, we know that this denominator cannot be 0. Well, this turns into if solving polynomial section or solving quadratics, right? This factor is pretty easy. This is what? X minus 4, x plus 3. Multiplies to give me negative 12, adds to give me the negative 1. Now look, you solve this just like you would solve a regular polynomial, a regular quadratic. So I'm going to set each one of these not equal to 0. I get x can't be 4 from the first equation, and x can't be negative 3 from the second equation. Yeah, I mean, it's all one equation, but from solving the quadratic. I mean, you can check that real fast. If I plugged in a 4 down here, 4 squared is 16, minus 4 would be 12, minus 12 would be 0. Yeah, that works out. Negative 9 squared is a positive 9, minus a negative 3, so it's plus 3, so that's 12 minus 12 as well. So yeah, both of these would make this equation be undefined. So now when we make the interval for this, it's going to be a little goofy because we're going to have 3 gaps, right? There's 2 numbers we can't be. So let's look at that. I'm going to start it here. We can go from negative infinity. The first stop would be negative 3, right? If we think of the number line, the first stop would be negative 3. Union, negative 3, right? Then it would go to 4. And then we could go from 4 to infinity. So that would be our domain, okay? And what this really is saying is we can be anything except negative 3, and except 4. We can be less than 3. We can be in between, or negative 3, I should say. We can be in between negative 3 and 4, and we can be greater than 4. But we just can't be negative 3 and 4, okay? So let's look at the second one. I'm going to solve it the same way, right? I'm going to say x squared plus 9 can't be 0. I could use the square root method here. So I'm going to move the 9 over. And I get x squared can't be negative 9. And when I take the square root of this, now remember when you take the square root, you have to add the plus or minus. So you wind up with x equals plus or minus. The square root of negative 9 is 3i, right? The square root of negative 9 is 3i. Okay, hey, I'm not worried about this. What this tells me is when I solve for my restrictions, right? Remember, these are called restrictions. When I solve for my restrictions, I got imaginary numbers. And if I got imaginary numbers, there's not a real number I could plug in here that would make this fraction go to undefined, right? There's nothing. I mean, let's think about this. Let's use our noggin here, not our algebra skills, okay? Let's use our noggin. If I take any number and I square it, and then I add 9, would it ever be 0? Right? Think of the number you're thinking of, right? You're probably thinking negative 3. No, negative 3, you should do this, right? But when you square negative 3, you get positive 9, right? And positive 9 plus 9, that's a positive 18. It can be down there, right? There's no way that this denominator could ever be 0. Now, algebraically, what happens when you do this, when you find this out, is that the restrictions wind up being imaginary, okay? Any questions?
I have a question.
I'm listening.
Why do you put the negative 9 in a square root of it? Why does it go from the x squared and then also to the 9 at the bottom?
Because it's just like an equation. Whenever you got to take this, whatever you do to one side, you have to do to the other. So we wound up with x squared can't equal negative 9, right?
Right.
And then if I want to get rid of the square root, this is a square root question. So if I want to get rid of the square root, I just take the square root of both sides.
Okay.
And then you wind up with the plus. Now, when you do that, you have to do the plus or minus. So you wind up with plus or minus 3i.
Thank you.
No problem. Okay, cool. Okay, so it turns out for this one, there's not a number that actually messes this up, right? We had to work a lot to find it. So therefore, it's just all real numbers. This one would be all real numbers. Okay, let's go over here to C now. And yeah, guys, if you got a question, just let me know, okay? It's hard for me on my end, it's kind of what Sarah was talking about. It's hard for me on my end to know, like if you guys were sitting in my class, I can kind of get a grasp. With math on, it's harder to know as well, but all of that stuff's just kind of gone. Okay, let's look at part C. So what about h of x equals the square root? There's our red flag, right? We've got a square root of negative x plus 9. So I'm going to set what's underneath this square root greater than 0, right? Negative x plus 9 has to be greater than 0. Move the negative 9. I get negative x is greater than or equal to negative 9. Okay, what's the rule? If I've got to get rid of the negative, what do I have to do?
Change the negative 9 into a positive 9.
Okay, if you divide by negative 1, you can. But what's the rule with inequalities? You guys remember this rule? Anybody in?
Flip the sign.
You got to flip the inequality. Yeah, you got to flip the inequality. So if it's a greater than or equal to, it turns into, you guys see that far over? Yeah. It turns into a less than or equal to. Now it's positive 9 now, right? Negative 9 divided by negative 1. Okay.
Oh, because the negative then that makes sense.
And it's kind of goofy on why that happens, but it's like if we use like regular numbers, if I told you that like 4, is greater than 3, right? If I make both of them negative, which is fine, right? That's not a true statement anymore, right? I'd rather have negative $3 than negative $4. So you have to just flip that inequality whenever you multiply or divide by negative. Okay, so let's make the domain of this guy. So x is less than or equal to 9. So that means it goes from negative infinity to 9. Remember, we got to use a bracket there because we can be the 9. We can be the 9. Okay. Lastly, the easy one. There's no red flags going on, right? We don't have an x in the denominator, right? This is just 4x plus 2 is a nice linear function. There's no square root, so therefore this is just all real numbers. We're done. I think this marker's almost done. Okay. Okay, cool. Now that we've done all, these are 4 good examples of different things that might happen in the homework. Do you guys have any questions before we go on? We've got 30 minutes. What I'll do, the next part. So the next part of the section is on combinations and compositions. So I'm going to go over the combinations, and I'm going to do combinations on Thursday. Okay, so we'll start that. I know we won't be able to finish both. We'll finish early today because of it, but there's no way I can finish both in one day. So let's do combinations today. Thrilling, I know. You guys are sitting on the edge of your seat, just waiting to learn about combinations of functions. I'll tell you, this is not hard. I'm going to tell you that up front. This is really not hard. But where students struggle with this is the notation. So that's why we're going over it. It's more about the notation of math for this part of the combination than the algebra. And you'll see this should be just a nice review of, arithmetic of polynomials. Okay. So let's look at a very basic example. Let's say I'm going to give you 2 functions. We've got the f function up here, is 3x plus 2. And I got the g function, which is, let's say, 7x minus 1. Okay, we'll keep it basic here for now. 7x minus 1. We'll throw another function up there just for fun. fg, we'll do the h. Oh, enough room, here we go. We'll say x squared minus 4. And we're going to do different combinations with all 3 of these. And in doing that, you'll see the notation, because that's really what we're going for. So the first combination, the most basic one, is addition, right? The sum of functions. So if I wanted to add any of these functions together, let's add the first two together, the f and the g. Okay, we'll call this a. If I wanted to add these together notationally, it looks like this: f plus g, not of h, but of x. Okay, f plus g of x. And all that is adding the f of x plus the g of x. That's it. Okay, it's just adding the f of x and the g of x together. Not too bad. So if we do this one, so we've got 3x plus 2. I've got plus 7x minus 1, right? It turns into just addition of polynomials, which is a kind of a pre-algebra, or I mean, it's an algebra topic, but pre-college algebra topic. With addition, it's nice. You don't have to worry about distributing. You can just add like terms, run out of room. Yeah. So we wind up with 3x plus 7x, that's just 10x. And then 2 plus a negative 1, so that's just 1. So we wind up with 10x plus 1. Very straightforward. Not a big deal at all. Okay. So let's do one where, what if we have a number? What if it's like g plus h of, let's say 5. G plus h of 5. Now you can start it the same exact way. You can say, well, that's just going to be g of 5 plus h of 5. There's nothing wrong in that. G of 5 plus h of 5, or x value is now the 5, right? And look, I'm just going to be a little lazy and I'm going to plug 5 in because these aren't too bad to do in your head. Look, g of 5, if this is the g function, that would be 7 times 5 minus 1. That's just 34, right? And then h of 5, well, if we go over to the h, 5 squared is what, 25? Minus 4, so that's going to be a 21. Okay, so if it's a number, you're going to wind up with a number, no matter what. Now, you might still wind up with a number with x. That's just if stuff just cancels. But if you start with a number, you're definitely going to end with a number. This winds up being what, 55? 55, okay? Any questions? What's up? That's a stretch, not a question. I just got so excited. Oh, I got a question. No, it's just a stretch.
I have a question. Where does this start getting hard? Like, what's the curveball?
Wait, well, say it again. It was hard to understand you, Rose.
What's the curveball?
What's the curveball?
Like, where does this get hard? It seems too easy.
Yeah, the composition part is the harder part. This is the combination part.
Okay.
And this is just about.
I knew there was a catch.
Yeah, we'll get there Thursday. Enjoy the easiness of this. Okay.
So you're always just adding them?
Well, so let's say we want to subtract them. If we subtract them, let's do g minus f. Okay, g minus f. So,
Okay.
yeah. So if we do g minus f, we're just going to do g of x minus f of x, right? And now we got to be careful with the minus to make sure everything subtracts. But I've got to get the order right for this one. So 7x minus 1 minus, now our f of x is 3x plus 2. And be careful. This, I'll put this on the test. It's probably going to be on the test. And I don't mean it to be I gotcha kind of thing, but I'm going to tell you half, if not more, of you are going to forget to distribute that negative to make this 7x minus 1. And it's going to be minus 3x minus 2. We'll forget to do that negative 2. It's just a quick forget thing. So we got some room down here. So this winds up being 7x minus 3x, that's 4x. Negative 1 minus 2, that's minus 3. And we're done. I'll say another common mistake, and it's kind of what Rose said, like, why is this going to be hard? Another common mistake is overthinking this question. and then like setting 4x minus 3 equal to 0 and then solving it out. That's not what we're doing. Okay, we're not solving. We're just subtracting, right? We're just adding and subtracting. And then we're about to get to multiplying and dividing, but that won't be hard for this section. Okay. Okay, so let's do, I mean, you guys get it if we put in a number. Let's say A, B, C, D. Let's do a multiplication. So if I wanted multiplication, and I'm going to write this as your book does. I'll tell you there's a few different ways to write it. But let's say we wanted G times H. Why not? GH of X. We'll do X first. GH of X. So if you see the numbers or the letters together, that means they're being multiplied. There's not going to be the symbol like the other two, okay? So it means multiplication. So this winds up being 7x minus 1 times x squared minus 4. And then we just have to FOIL it out. We're not going to leave it in this factored form for this section. We're going to FOIL it out completely and see what we get. So first we get what? 7x cubed. Outside, we get minus 28x. Inside, I get a minus x squared, right? And then lastly, I get a plus 4. So wait, there's no like terms here. Now I'm going to write this in descending order just because it would bother me to put the x in front of the x squared. That's a me thing. So this would be 7x cubed minus x squared minus 28x plus 4. If this was a regular test on paper, I would take this one as a correct answer. Now, of course, this will probably be a multiple choice question, and you'll see which one it is. Not a big deal. Now, if it's multiplication, it's kind of nice because you can just plug them in and multiply them. So if we have, let's keep going. A, B, C, D, E. Let's say we wanted to multiply F and H together. Let's say we want to do FH, but then let's choose a number. Let's say 1. Why not make it easy? Okay, FH of 1. It's really F times H of 1. Now you can think of this as F of 1 times, not G. Let's start with G. G of H of 1. Okay. F of 1 times H of 1. So we just need to find F of 1, we need to find H of 1, and we just multiply it together. It's not too bad, right? So if we go to F of 1, here's F. So if it was 1, it would be what, 3 plus 2, so 5. So F of 1 would just be 5. H of 1, 1 squared is 1 minus 3. That gives me what, negative 3? So this gives me negative 15, okay? Negative 15. Sure I'm on the right path here. Don't think anything off. I don't think they go into. Yeah, okay. And then lastly, we can divide them, A, B, C, D, E, F. For division, actually, it's really easy in this section. You just put one over the other. Your book notates it. Let's do like F and G here. So F over G of X. So this is just going to be F of X over G of X. So F of X would be 3x plus 2. And G of X would be 7x minus 1, right? Now, we can look to see if there's something that simplifies, but remember, with this simplification, you've got to have something that divides into all 4 parts, okay? So if something does simplify, it's got to divide into all 4 parts. Nothing does here. I don't think there's one at all I can make up that does that, okay? And hey, you know what? Just to be, I'm going to be lazy here, sometimes called efficient. I'm going to keep the same fraction, but let's plug in a number like 4. So F of G of 4. Now, if I've already found the fraction, I can just plug that into the fraction because I've already found it, right? I know what F of X over G of X is. It's this. So I can plug 4 into here. So it would be just 3 times 4 plus 2 over 7 times 4 minus 1. I'm sorry if it's hard to see that. It's really hard to write at your waist. So the numerator becomes 12 minus or plus 2. So that winds up being 14. The bottom is what, 28 minus 1, so 27. And I don't think anything simplifies from that. 14 is 7 and 2, that's not divisible by 27. So we are done. Okay. Questions? Comments, concerns?
So you wouldn't have to simplify that. There's no way.
Which one, F or G there, Rose?
G.
No. You can't simplify 14 over 27. But if you could, if it was like 14 over 28, you'd say it's 1/2, right?
Yeah.
But, yeah. If you could simplify it, you need to simplify it. But that doesn't simplify any further. Okay, so now I need to get, do you guys have your book with you, on you? Get your book out real fast, because I'm going to try to describe this example. If you've got your book on Zoom, you need to take your book out and go to page 298. There's an example in there of a graph, and I'm not going to draw the entire graph, but I'm going to bring out information from the graph and talk about it in the lecture. Okay? So it's page 298. Numbers, we can start with we'll do the evens. Let's do number 84 first. Page 298, number 84. Page 298, number 84. And notice with number 84, it's really like 80 through 90. There is a graph given. And in that graph, you've got a blue line that represents f of x. So I'm going to write that down just to see what's going on. F of x equals the blue line. And g of x equals the red line. Okay? And it gives us all the coordinates right there on the graph. And it asks us to do different operations, but it doesn't give us the function like it did before, like the examples before. We actually just have the graph. So let's look at number 84. 84 asks us to find, actually we'll probably do the evens here. 84 is g minus f, is it of -2?
-2.
Thanks, sir. G minus f of -2. Now, for this one, we're going to remember that it's just g of -2 minus f of -2. So g of -2 minus f. Now, we got to use the graphs here, right? So first, if I want to find g of -2, remember this is the x value. So the g is the red line. So I'm going to go to my graph, and I'm going to go to the red line, and I'm going to look and see where x equals -2. So to me, it looks like where x equals -2, the red line is a +2. Like if you look at that coordinate, -2, 2, that's where the red line is. Do you guys see that? I need you to visually see this. G of -2 just gives me, it's really the y value. This is the y value, right? The g is this is the function notation, a fancy way of saying y. So g of -2, so the x, when x equals -2, the g function pops out +2. Minus, now we need to find f of -2, the blue line, right? So if I look at the blue line and I go to x equals -2, I got to go up to what? +3? So when x equals -2, the y value for the blue line is a +3. So I found my g of -2 and my f of -2. Okay? G of -2 and f of -2.
I thought we were gonna have to actually make
No. We're not making the formula. That would be a very difficult formula. Okay, you know we talked about piecewise function? That's like 1, 2, 3, 4. There's 4 piecewise functions just for that blue function. Okay, so 2 minus 3, that's going to be -1. Okay, we can do that part. 2 minus 3 is -1. Okay, now I'll tell you, it's okay if you're like, I have no idea what's going on. Usually this takes, if this takes a few examples, and then once it clicks, it just clicks, okay? So it is a-okay if you're not getting this right now and you feel really lost. Just listen to me and then look at the book while I'm talking about this one. Okay, so let's do 86 now. Man, my markers are going, I gotta get some more markers. They lasted a month, that's not bad. Half a month. Okay, so 86 says find G over F of, what was it, 3? G over F of 3. And I got to be careful, the G's in the numerator. Okay, so I've got to find G of 3 over F of 3, right? G of 3 over F of 3. Now remember, so for each one of these, the X value is going to be 3. So let's look at the G. Now the G was the red line. So I'm going to go back to my graph, and I'm going to go to my red line. And when X equals 3, where is my red line? It's on 0. You guys see that? When X equals 3, our line, the red line, is actually an X-intercept, okay? So that's pretty cool. I mean, that means this numerator is going to be 0, which means the whole thing's going to be 0 unless we're dividing by 0. So let's look at F of 3. If we go to the F function now, if we go to X equals 3, what's that, -3? I think that's -3. Tell me if I'm wrong.
Yes.
Yeah, -3. 1, 2, 3. But guess what, guys? If you take 0 and you divide it into anything, it's always 0, right? The 0 just can't be in the denominator. This will always be 0, okay? 0 on top is fine. It just can't be in the denominator. If we flip this, like if we did, so this is, let's say 86b. If we did F over G of 3, this would be -3 over 0 because it's the inverse. This would be undefined, okay? Because the 0 would be in the denominator. Oh, man. Oh, this is a good question. Huh. Yeah, the domain of, I don't think I've ever really looked at this one. I usually don't have as much time to go over like combinations. Usually I have to like zoom through them. So it's kind of fun to get to sit here for a minute and talk about it. 88 says find the domain of F over G. Domain of F over G of X. Domain of F over G of X. Man, I got to think about this. I mean, if we've got these two functions, the domain can't start until they both exist, right? I'm going to give you an example. Let's say I asked you to find F of, or let's say the value was -5. F of G of -5. Let's just say we'll make that, A here. I want you to find F over G of -5. Will you tell me, hey, this is F of -5 over G of -5, right? Now, if you look at the graph, the F function does not exist at -5. You guys see that? The blue line doesn't go that far left. The blue line starts at -4. So therefore, look, that does not exist. So I'm just going to put D and E, does not exist. And it's because of F. Now, G of -5 does exist, right? G of -5, we're at what, 0?
-1.
Oh, -1, did I lie? I'm sorry. We're -1. So that means, look, we can only, the domain can only exist when both of these exist, right? Where both of these exist. So let's just look, so if you look on the graph, they both start existing from -4. I'll write this down. from -4, and this, you know what, I'll put the x values in there because we're talking about domain. So x equals -4 to, would it be 3? You guys agree with that? The blue line stops at 3, right?
Yeah.
Yeah, the blue line stops at 3. So they can only exist from -4 to x equals -4 to x equals -3. Okay. But we have the other issue of dividing by 0. We've got to find where g of x equals 0, right? Remember, I mean, f over g of x is f of x over g of x, right? So we need to know where g, where the y value, what x value makes the g of x equal 0. There's one of them, right? We know one of them from the last one. If you look now, we're looking at the red line now. At x equals 3, x equals 3 makes g of x 0, right? What other x value is going to make g of x 0?
-4.
Ooh, -4. Is that in our domain? Ooh, it is in our domain. X equals -4. Makes g of x equals to 0. Okay, so we're gonna build this domain interval, right? We've got to build this domain interval. It's kind of crazy. So it goes from -4 to 3, but it can't be -4. Because look, if I plugged in -4 here, if I plugged in -4, I'm not sure what this is, but I know g of -4 is 0, right? So therefore it doesn't exist. So it's got to go from -4 to 3, but it can't include -4, and it can't include 3. Is that what we have going on? So it can be anything between -4 and 3 except the endpoints. Boom. There we go. We just use parentheses then, right? So we can be anything between -4 and 3, but we can't be -4 and 3, so we're going to use parentheses. That's a curveball question. That one's not the easiest. Okay, so for homework now, it went longer than I expected to. For homework, I want you to do, I'm going to get very picky and choosy on this homework because of the domain section mainly. So it starts on page 297. This is 2.6. So I want you to do 1 through 8. I want you to do all of those. That's not just odd, 1 through 8. And then I want you to do 17 through 24. So probably be the only even ones I assign this section. And it's because I just don't like the other questions in that section. And then 31 through 49, these are going to be odd. So 31.
What is the 17 through what? You've got the black boxes in front.
Oh, I'm sorry. 17 through 24. Is it not coming through there? 17 through 20. Oh, I think if you make your screen bigger, Jeanette, maybe if you expand it out, can you see it? I'm sorry about that. I can see it on my.
Thank you.
Yeah, no problem, no problem, no problem. So 31 through 49, odd. Okay, you don't have to determine the domain though for each of those, okay? 31 through 49, you don't have to do the domain, except if you look at those, it says, it wants you to find f plus g, f minus g, f times g, and f over g. And it also wants you to find the domain for all of them. Don't worry about doing the domain for all of those. Just find the operation. You could probably do every other odd on that one and be okay. Okay, and then I want you to do 83 through 89 odd. 83 through 89 odd, which is what we just went over. Okay, and then, I know, but wait, there's more. I want you to do 97 and 99. They're just real world questions where these pop up. 97 through 99. Okay. So that's the homework. So 1 through 8, and then 17 through 24, and then 31 through 49 odd, except the domain question, and then 83 through 89 odd, and 97 and 99. Okay, and then when we get back to class on Thursday, we'll go over compositions, and we'll probably start 2.7. I don't know if we'll be able to get done with both in one day, but we don't have to rush. We're really a day about kind of a half day ahead. Okay. Questions online? In here. I'm going to pause this.